Hello everyone, and then welcome to another tutorial video. So in this video we'll be treating what's an application to partial derivatives, which is what implicit differentiation. Okay, so I promise you that this video is very precise, straight to the point, and very short, so that it will help augment your study. And then without further much ado, let's dive right into this video. But before that, I will urge you to subscribe to the channel if you are new, and then in case you are an old subscriber, thank you for subscribing. And then in case you are a new subscriber, I would urge you to subscribe to the channel, turn on your post notification so that you don't miss out on future videos. Like the video, help share the video. Let's dive right into the main concepts under what's implicit differentiation with the application of partial derivatives. Okay, so we already know how to implicitly differentiate functions, okay, but how do we do that with respect to what partial derivatives? That's what this video is all about. Now, so you'll be given what function z with what both x and y mixed within the what expression, okay? So that's what partial derivatives are. So you try to differentiate with respect to one specific variable, okay, and then you try differentiating with respect to another specific variable, okay, right? So for this case 1 involving implicit equation of x and y, so we have what dz. So this is the main expression, okay? So we are trying to expand this. So we have what dz, we have f of x dx, and then we have what f of y dy. This is just the notation. I'm trying to give you the notation, giving you the background to what the main concept of what implicit differentiation and what partial derivatives. After that, I'll give you the exact expression you need in order to what differentiate. There's no need to go through all this kind of expanding and all that, okay? You just need just one specific expression. You use that approach and you are good to go. But let's first go through the main explanation, okay? So from here you have what when you differentiate this. So when you differentiate dz respect to x and y, so we have what dz, okay, that's equal to what f of x respect to dx, and then f of y respect to dy. And then when you assume y as a function of x, you end up with what dz dx. So all we are doing is just making what dz dx the subject from this expression, okay? That's all they did. They just made, okay, dz dx, okay, dz dx the subject, and then we came up with this. So from here you have what dy dx, okay? So we are working this in the form of what dy dx, okay? We are not using the z dx. So we have what dy dx, and then we end up with what f of x, f of y. Now there is no need to know all these, okay? There's no need to know all this. This is the only thing you need to. This is the only thing you need to know. This is the only formula you need to know, okay? Keep this formula in mind. This is the only formula you need to know. Whenever you are told to implicitly differentiate a partial derivative, all you need is this formula. So this formula, let me explain this formula so that you proceed from there. So now we have what dy dx, okay, equals what minus f prime of x, f prime of y. So what this means is that we are partially differentiating x with respect to what we have. So the expression could be what a mixture of x and y. So you just partially differentiate x only, okay, and then you partially differentiate y only. So in case you've watched our video on partial derivatives, this will be very simple. So let's take an example so that you get to understand how simple implicit differentiation under the application of partial derivatives are, okay? There's no need to go through the traditional solution. I could take you through the traditional solution, but that won't help you augment your studies, because that's what everybody on YouTube is trying to teach you. But I'm trying to take you through the simpler route, okay, or routes, irrespective of how you pronounce that. That depends on you. Okay, so let's see how we solve this. So we have solution, okay, so we have what this is dy dx. So just keep the formula in mind. That's the most important thing. So f prime of x, okay, and then you divide that by what f prime of y, okay? So let's see how we solve that. It's just partial derivatives, okay? Just partial derivatives. Just keep in mind that all you are doing is just partial derivatives. Now keep this negative sign over here. Don't harm that negative sign. Now partially differentiate the whole of this expression with respect to what x, okay? Partially differentiate the whole of this expression with respect to x. In case you cannot see the expression, let me use another color to write out the expression. So we have what 3x squared y minus what 4s squared plus what 3 plus 7y equals 10. Okay, so one thing I didn't state initially, okay, so whenever you are solving partial derivatives with respect to implicit differentiation, or in general, whenever you are solving implicit differentiation in general, always equate the entire expression you are given to 0. Okay, always do that. It's very, very important. So let's equate everything to 0. 3x squared minus what? 4x squared plus 3 plus 7y minus what? 10 equal to 0. So this is what we are looking for. Equate everything to what? 0. This is what we will be focusing on. Okay, this is what we'll be focusing on. So now let's try do what? Partially differentiate with respect to x. Okay, only this expression. So when you do that for here, you end up with what? So from here we have 6xy. Okay, we are partially differentiating with respect to what? X only. So this is how we solve implicit differentiation. Keep that in mind. This is how you solve implicit differentiation. The formula is very, very important. Once you know the formula, you are just good to go. There's no need to harm yourself trying to prove anything. Okay, so let's proceed. So we are done with the first one. So let's move on to the second one. So we have what? Negative. Okay, so we have what? Just differentiate this. You end up with what? 8x. Okay, so let's proceed. So we don't have any x here, so this goes to 0. We don't have x here, this goes to 0. We don't have x here, this goes to 0. Okay, now let's look at the denominator. Okay, let's look at the f prime of y. So now after partially differentiating with respect to x, now we have to partially differentiate with respect to what? Y. So the same approach, start from the beginning. So when you partially differentiate this with respect to y, you end up with what? 3x squared. Okay, because y will go to 1, y will be differentiated, and then you get what? 1. Now this goes to 0 because we don't have any y over here. This also goes to 0. Okay, we don't have y over here. And then we have what? 7y. So when you differentiate that, you end up with what? 7. Okay, and then we are done because 10 will go to 0. You are good to go. Okay, this is very, very simple. Very, very simple. This is how you do implicit differentiation when it comes to what? The application of partial derivatives. There's no need to go through the general route. I could teach you how to go through the general route, but there's no need for that because this is what this channel is all about, trying to help you learn smart, not hard. Okay, that's what this channel is all about. I could just take you through the general approach right now if you want, but I don't know whether most of you might want that, since after knowing how to arrive at this answer. Okay, but let's just go through the general route, okay, so that you get to understand what all this is about. Okay, so for going through the general route, okay, that's per using this kind of expression and all that. So the traditional way, you'll be told to do this. Okay, so you'll be told to keep y in check. Okay, because you are solving for what? dy dx. Okay, always keep y in check. So we have something like what? 3x squared. Okay, dy dx. Okay, just look at what I'm doing, and then we have what? Plus what? Differentiate this, you end up with what? 6x, and then you proceed over here. So you differentiate this again, so you have what? Minus what? 8x, and then you proceed to this point. This goes to 0, and then you have what? 7. Okay, so plus what? 7 dy dx. So I'm showing you the traditional approach. This goes to 0. Okay, so this will go to 0. Okay, this is how the traditional approach is. Okay, you use something like a product rule. Okay, so you differentiate one and then you keep the other. After that, you differentiate the other. But the ones which have what? But when you are trying to differentiate with respect to y, you keep what? These dy dx attached to them. Okay, so let's proceed. Let's just make dy dx the subject. So we have what? Dy dx. Right from here, you could note that we have what? 3x squared. Okay, and then we have what? This is 7, right? So we have plus 7. I'm just doing simple factorization, and then let's send this to the other side. Okay, let's just move it. So we have what? 8x. Okay, and then we have what? 6. So we have what? Minus 6x. So making dy dx the subject, you just end up with what? 8x minus what? 6x, and then you divide that by what? 3x squared plus 7. Okay, and then you are done. Okay, so this is the traditional approach, and then this is the what? simpler approach. Okay, so you can notice that negative sign is over here, so the negative sign is affecting the numerator. Okay, so that's the same thing you get over here. Okay, that's the same thing you will get over here, because this will be what, positive 8x minus 6. That's the same thing over here. Okay, so this is what just the traditional approach. But once you know simpler approach, just like how I introduced to you over here, okay, let me just circle that. Just like how I just solved this in less than 5 seconds. Okay, you could just solve this in less than 5 seconds if that is not too exaggerated. Okay, you could just solve that in less than 5 seconds, and then you are good to go. Okay, there's no need to go through this. Okay, once you know how to solve this, you are good to go. Now let's look at what next item. Okay, let's look at the next item. So sometimes you'll be told to use cases involving x, y, z. So we were given only x and y. Okay, that's for what we did previously. We were told to find the implicit differentiation in less than with x and y, but sometimes you'll be given x, y, z. Okay, so once you are told to do that, all you have to do is just follow the procedure. Okay, you've been given the x, y, z, but given a specific notation with what, w. Okay, so you differentiate with respect to w, so across x, y, and z. So you have dw, differentiating across dw, you have f of x, d of x, plus what, f of y, d of y, plus f of z, d of z, being equal to 0. Now you're taking everything with respect to what, x and then y. Okay, so we have zx giving us minus f of x of divided by what, f of z. So we are differentiating x with respect to z. Okay, keeping things in check. So that's why we have zx, and then we have zy, the same thing, f of y minus f of z. Take note of what, the negative signs. Okay, now there's no need to do this. Once you know this formula, you are good to go. That's why I always give you the exact stuff you need to know, but I just end up giving you what will help you succeed. Okay, I just give you the general approach, and at the end I give you what will help you succeed. This is the exact expression you need to know. Okay, don't worry about the rest. When it comes to 3 variables x, y, z, this is the only two this one and this 2. Okay, these are the only 2 formulas you need to know. So let's do that. Let's try do that. Okay, let's try use it to solve this question. Okay, so we have zx and then zy, and then we already know that. Okay, as I stated earlier, always equate everything to 0 over here. So we've just equated everything to 0, and now let's find out z of x, which is minus f prime of x. Okay, keeping s in check, divided by f prime of z. Okay, that's what it implies. Okay, f prime of x, f prime of z, just like what we've written out over here. Okay, just like what we've written out over here. Now, so in order to arrive at your answer, just keep your negative sign, then you partially differentiate with respect to x over here. So from here we have 2x. We do not have any x variable over here, so everything goes to 0, and then you divide that by f prime of z. So no z over here, no z over here, but you have z squared over here. This is z squared. Okay, so that's 2z. So you can just simplify this further to get x on z, and then you are good to go. Okay, now let's find out z of y. So for z of y, use the same principle, but from here we are using y as a reference, and then you have f prime of z. Okay, now so from here let's keep a negative sign. Let's try it from here. So we have f prime of y. So from here you have f prime, that's 2y, because there's no y over here, there's no y over here, there's no y over here. Okay, they go to 0, and then we have f of f prime of z, which is 2 z. Okay, same principle. So this goes to minus y on z. Okay, this is very, very simple, very, very accurate. Okay, very, very simple and very, very accurate. That's all you need to know. This is all you need to know. So in case you enjoyed watching this video, I would urge you to subscribe to the channel, turn on your post notifications so that you don't miss out on any future video. Like the video, share, and then I will see you in the next video. Have a lovely day. Bye bye.